In perfectly elastic collision, what happens is that momentum, yes, here, momentum is conserved. Okay, but the kinetic energy after the collision of the two bodies, quickly the two bodies join to form one unit, or what we call as composite body, and travel with a common velocity. So for conservation of momentum, m1 u1 plus m2 u2, which is equation for the conservation of momentum. After collision, m1, m2 combine, they join, and they all move with a common velocity v. Okay, so after collision, for perfectly inelastic collision, the two bodies after collision combine to form a unit or one body, and then move with a common velocity. An example of this is the motion of when two vehicles, okay, collide. Yes, Inshira?
Please, I thought because momentum is conserved, it will be the same equation as the other one.
As which one?
The MAUA plus MBUB is
No,
equal
this
to.
is what happens. You see, after collision, it is M1 V1 plus M2 V2. But for perfectly inelastic collision, after collision, the two bodies become one and move with one velocity. So V1 is equal to V2. And because V1 is equal to V2, the equation becomes M1 U1 plus M2 U2, which is equal to M1 plus M2 times just the velocity V. Because assuming these velocities is 5, assuming we have 5 meters per second, then it will be M1 times 5 plus M2 times 5. And this is similar to, this is 5M1 plus 5M2. And so, Inshira, is just the same as factorizing 5 out, but adding the masses. Okay, so this is the common velocity V. Are you answered?
Yes, yes.
Now, if they are moving with common velocity after the collision, then for perfectly inelastic collision, then we can also say that the kinetic energy of one plus the kinetic energy of 2 is also equal to, let me write it in terms of formula. Then this is what we can also say, half m1 u1 squared plus half m2 u2 squared. This must be equal to half m1 plus m2 times v squared for perfectly inelastic collision. Then we can also say this for perfectly inelastic collision. Let's solve one or two problems for perfectly inelastic collision so that we can master how it is applied in solving problems. I'll drop the question on the platform. This collision chain
Mr.
can also.
Dia,
Hello.
so the first one with the M1 U1 plus M2 U2 is equal to M1 plus M2 V. That one is
For
there
momentum,
like conservation of momentum there?
for perfectly
And then
inelastic,
and then the half one is
for
conservation of
kinetic
kinetic
energy.
energy. Okay.
Okay, so I've sent the question to the platform. Please take note. So a heavy duty truck with a mass 3 times 10 to the power 4 kilogram traveling at 15 meters per second collides with another similar truck of mass 2 times 10 to the power 4 kilogram and traveling at 10 meters per second. They move together. They move together after the collision. They move together after the collision. So what is missing is they. They move together after the collision. Let me find their common velocity if the tracks were traveling A in the same direction, B in opposite direction. Please, once you are told that find their common velocity, it means the collision is perfectly inelastic. Okay, so I want you to give it a try. Let's see how you go about this question. Find their common velocities if the tracks were traveling A in the same direction and B in opposite direction. So start with. Okay, so the first question. Please, those of us who are new on Omega, if you are new on Omega, right after the class, give me a message. If you join today within the week, you let me know so that I can see what to do to help. Okay. If the bodies are moving in the same direction, then okay, I earlier told you that once they are moving with a common velocity, it means this is a perfectly inelastic collision. So the equation to that effect becomes M1 U1 plus M2 U2 is equal to M1 plus M2 times V. Times V. Okay. And this is if they are moving in the same direction. When they are moving in the opposite direction, simply M1 U1 minus M2 U2 would be equal to M1 plus M2 times V. And this is on condition that momentum of 1, P of 1 is greater than P of 2. If it's the other way around, then you subtract M1 U1 from this. So let's look at it for the same direction. Momentum of 1 will be its mass 3 times 10 to the power 4 times, I'm coming. Hello, Grace. But talk, man. What do you mean about money? Oh, Grace, I'm having a class. So M1 is 3 times 10 to the power 4, and then U1 times 15 minus M2. M2 is 2 times 10 to the power 4 times its velocity is 10. This must be equal to M1, which is 30,000 plus M2, which is also 20,000 times their common velocity V. The rest has to do with multiplication. This is 45. 5 times 10 to the power 4 minus 20 times 10 to the power 4 is equal to 50,000. 50,000 V. 45 minus 20 is 25 times 10 to the power 4. Are we there? Class, are you there?
Yes, please.
Okay. Hey, hello, please. What we are doing, we've taken it for when they are moving in opposite direction. You take notes. We are rather answering the B when they are in opposite direction, when you subtract. So this is for the B. Therefore, V is equal to 25 times 10 to the power 4 divided by 5 times 10 to the power 4. So what's the final answer?
5 meters per second.
I'm coming. This is 25 times 10 to the power 4. And then I'm coming on. This is 30,000 plus, so 50,000. Okay. Oh, okay, okay. All right, so V is equal to 5 meters per second. That is the velocity when they are moving in opposite directions. When they are moving in the same direction, the only change will be the operator in between them. So this will change to plus, and that's all. Okay, so in that case, the total momentum will be 45 times 10 to the power 4 plus 20 times 10 to the power 4 is equal to 50, 5 times 10 to the power 4 V. When they are moving in the same direction. And here, instead of subtracting L, this will be 65 times 10 to the power 4. Is equal to 5 times 10 to the power 4 V. V therefore is 65 on 10 to the power 4 divided by 5 times 10 to the power 4. And what is 65 divided by 5? Again, this is 13. 13 meters per second. That does it. So the good news is that, in fact, this collision is also a topic in elective maths, and you'll be taken through something like this. Okay, so once you get it right here, you can easily apply in A-maths.
Mr. Dear,
Hello.
what about from the formula, the first one that you did? You just go straight to it. You don't go it according to what you did.
I don't get you. From which? From the formula above. From here.
From V. Yes.
But Lizzie, what I'm doing is the same thing. I'm only substituting values. This is M1 V U1. Okay, so I haven't done anything different from the formula.
Yeah. So with this, then you divide both sides by M1 plus
Yes,
M2.
that will also do.
Then-
And this is what you are asking. That's if they are moving in the same direction, then V will be equal to M1 U1 plus M2 U2, all divided by M1 plus M2. Is that what you are saying?
Yes.
You are right, but I don't want you to see it as a formula. If you learn it as a formula, when you are not able to recall the formula, you may not be able to connect that. No, this thing comes from conservation of momentum. You will still be thinking, hey, the formula is missing also. So I don't want you to see it as a formula, but understand it from the conservation principles. Are you okay?
Mr. Dear,
Hello.
please, my network was misbehaving. Please, could you like go through it again? I wasn't
No,
hearing you clearly. Your
no
voice kept on
problem.
breaking.
Yeah, no problem. Okay, so we are looking at perfectly inelastic collision. So in a perfectly inelastic collision, the two bodies join, forming a unit or a single body and move with a common velocity v. Now, if before collision, the two bodies are moving in the same direction, so M1, then this is M2, its velocity is U2. Then after the collision, they combine M1, M2, and then move with a common velocity V. And this is what happens when, unfortunately, a bigger car and then a smaller car collide. The bigger car, because it has a greater momentum, would continue to move and then ride the smaller car along. So if they are moving in the same direction, then M1 U1 plus M2 U2 is equal to M1 plus M2 times their common velocity V. So in the question I just gave you, that is what it is. We have to find the common velocity if initially both cars are moving in the same direction and if they are moving in opposite direction. So the mass of the first car is 33 times 10 to the power 4. Its velocity is 15. Its initial velocity is 15 plus the mass of the second car, 2 times 10 to the power 4. Its initial velocity is 10 meters per second. And this must be equal to addition of their masses and then times their common velocity. Okay, this is 45 times 10 to the power 4 plus 20 times 10 to the power 4. This is equal to 30,000 plus 20,000, giving us 50,000 V. So V is the common velocity. Okay. This plus this, we have 65. Hello. 65 times 10 to the power 4, which is equal to 50, or 5 times 10 to the power 4, V. So dividing through by 50,000, you have 65 on 5. And this is 13 meters per second. This is 13 meters per second. Millicent, are you okay?
Yes, please.
If they are initially moving in opposite directions, this is what it means. M1 is here, U1. Then M2 is coming from the opposite direction, U2. Now after collision, they will still be, because the collision is perfectly inelastic, they will still combine. They will still combine M1, M2, and move with a common velocity. And here the value of V will tell whether after collision they will still be moving here or they will go to the right or left. So the equation becomes M1, which is, so the only difference here is that we will subtract the momentum of this from this one because this has a greater momentum than this. So we have 45 times 10 to the power 4 minus 20 times 10 to the power 4 is equal to the same thing, 50, or 5 times 10 to the power 4 B. Okay, then when you subtract, 10 to the power 4 is common. So when you factorize it out, you have 45 minus 20. And this is 5 times 10 to the power 4 V. 45 minus 20 is 25. So you have 25 times 10 to the power 4 divided by 5 times 10 to the power 4 is equal to V. This and this will cancel. And when they are moving in opposite direction, V is equal to 5 meters per second. Milli. This is your solution. All right, so this is it. For inelastic collision, perfectly inelastic, perfectly elastic, not so difficult. You just must understand what okay goes into each one, and you can always be able to apply it in solving problems. Millicent, what's the question?
Miss Delia, please, can you move your camera a little bit?
Up.
Yes, thank you.
Okay, so I think we are about 5 minutes. If you have any question, quickly ask. If you don't have, I think we'll call it a day. Okay, but I have that brainy relationship between kinetic energy, find the ratio. But next week we are starting a different topic. I'm looking at either light, geometric optics, light, or pressure. Okay, so you have to make time and then attend in your numbers next week. So until then, please take care of yourselves and bye-bye. I'll send you work set. When the work comes, do. Okay, bye-bye. Yeah, who is coming? Elvina.
Miss Delia, Miss Delia,
Hello.
please, can you move your camera down?
Down. Okay.
Yes, please. Thank you.
Are we through?
Yes, please. Thank you.
Okay. All right. Bye-bye.